Hello, we are Zen. I'd like to start with a couple questions for the audience. Who in the past week has used a bicycle, ridden a bicycle? Please raise your hand. Great. Who in the past week has driven a car? Great. So we decided to tackle the problem of communication between cyclists and vehicles. We started by thinking about our own experience and also looking at some crash statistics for the city of Boston and the surrounding area. There are a number of bike crashes here every year, and a lot of them are quite serious. There are four main types of bike crashes. There are car doors, there are cars approaching from the rear and overtaking, there are pedestrians that aren't paying attention to, and cyclists that then run into this conflict, and there are road conditions. And so with this in mind, we rigged up a scenario and that tried to capture all of these, and we thought about what systems might intervene and allow the cyclists to get a better understanding of what's happening around them. So we looked at feedback mechanisms on the helmet. We worked with auditory feedback. We worked with visual feedback in the form of lights. We worked with haptic feedback in terms of vibrations. And we pulled those together to create a prototype that we use this video, in which a cyclist encounters all four of those different crash scenarios, or to run some user tests out on the streets of Cambridge. So we're gonna listen to those right now.
I think the audio's not working. Yeah, but we have subtitles.
All right. So the subtitles will be up shortly, but basically we had some interviews. There was a lot of positives, there were a lot of negatives. But through this, we kind of adapted what feedback we prioritized in which situation. So there were some questions that came up during the ideation about how to prioritize which signals to use at which time, whether we can use, just beeping all the time is a little overwhelming. A lot of vibration we heard was, too much, confusing. If you use voice all the time, maybe you won't hear that. There's a truck passing, and that's when you need it the most. And so through this process, we kind of narrowed down what feedback to use when, and that was actually really valuable to get this in-person, on-the-street reactions. And so what we prototyped and tested were the feedback mechanisms, but you may be wondering where's the helmet getting this information? So one of our team members is a computer vision expert. We talked a lot about how kind of an autonomous vehicle piloting system could be integrated with the helmet design to allow for effective obstacle tracking, pedestrian tracking, and vehicle tracking around the car, as well as some LiDAR to detect pavement conditions, which is useful at night as well. Thank you. And how these might be communicated not just to the cyclist, but we're thinking about a future of semi-autonomous and autonomous vehicles. So we want to have the bicycle be a part of this connected future, right? So these predictions will allow the bicyclist to participate in the vehicle-to-vehicle protocol. And we're also thinking about how the gyroscopes and sensors, the helmet is, the head moves around, tracks where people are going. And so a machine learning algorithm combined with the gyroscopes and accelerometers in the helmet could start to learn when a bicyclist moves its head like that, they're about to swerve out into the lane. So that can be communicated to cars around them to help expand the uncertainty space at certain opportunities, so the cars recognize that this is something and the bicyclist knows that they're safe proceeding out into the lane, because the car, maybe not the driver, we're trying to bypass the emergencies, awareness of the driver, because that's unpredictable sometimes. But that allows the bicyclist to be part of this connected world without modifying their behavior in a way that makes this sort of participation unwelcome. And we're also, the helmet-mounted system is great because it's not just for cyclists, it's for electric scooters, it's for hoverboards, it's for any sort of personal mobility device. And it's platform-based, it's not dependent on a larger system, and it can be integrated and deployed right now. Thank you very much. Yeah, if anyone would like to try on the helmet and experience the feedback mechanisms, we can do that, but afterwards, yeah. Oh, sure. So on the helmet right now, we have 3 different feedback mechanisms. We have a series of lights underneath the brim that are controlled by a Raspberry Pi up here. We had them correspond to different types of obstacles on the road. We had some speakers attached to the side, which provide verbal and auditory beeping type warnings. And we had a haptic feedback provided through a game controller controlled through the computer to vibrate at the appropriate time with the video. We also have a camera up here just to test the feasibility of that kind of machine vision prototyping. We didn't, yeah. So that's what's on the prototype right now.
Sure.
Yeah, sure.
Thank
Thank
you.
you. Thank you.